This video presents a simple description and experimental validation for our research titled Vision-Based Autonomous Drone Landing on Moving Platforms with Uncertain Motion via Deep Reinforcement Learning. Drones today are used in many different tasks. Autonomous landing improves the overall efficiency of drone operations. Vision-based landing enables this without any extra infrastructure, using only the onboard camera. Landing on moving platforms can further increase operational efficiency. However, when the platform accelerates, the drone's camera view becomes unstable, making detection difficult. Therefore, vision-based landing should be treated as an active perception problem, where the agent learns perception, aware actions that consider detection and estimation together. This study proposes a deep reinforcement learning framework for autonomous landing, which integrates robust visual detection and reliable state estimation. Simulation experiment. The proposed method is evaluated under diverse landing scenarios. Case 1. Constant forward motion at 8 meters per second. Case 2. Forward motion with time-varying acceleration. Case 3. Circular motion. Case 4. Zig-zag motion. Case 5. U-turn maneuver. Case 6. Sinusoidal vertical motion. Real-world experiments. For the stationary landing platform, although this case was not included during training, the drone still lands successfully. For a moving platform, when the drone overshoots and the platform goes out of view, the agent slows down to regain detection. Even when the platform suddenly stops, the agent tracks it smoothly and adjusts its altitude to secure detection before final landing. And other trials confirm that the system consistently achieves stable landings on the moving platform across multiple experiments. These results show robust performance in challenging scenarios that are difficult for conventional landing algorithms, such as high acceleration motions where the landing pad temporarily leaves the camera field of view, and near touchdown phases where only a small portion of the pad is visible. They also confirm successful sim to real transfer of the proposed method. Thank you.